Okay, now for each of the following, find f composite g, state the domain, g composite f, state the domain. So we start with example A. Keep in mind, anytime I use this, anytime I see the square root of x plus 2 being used, I know that x plus 2 must be bigger than or equal to 0, or x must be bigger than or equal to negative 2. So that's something I should keep in mind whenever I use this. So when I start with f composite g of x, that's actually f of g of x. That is f g of x is actually square root of x plus 2. Since I used it, that domain carries with it. And that's going to be the square root of x plus 2 squared, which is x plus 2. So one can look at x plus 2 and say, wait, there's no radical, there's no fraction, there's no log, but the fact that I used this function in it, the domain carries with it. My domain would be x has to be greater than or equal to 2. You could use interval notation if you prefer. That's pretty much the same thing. And I get to the second part. If I want to find g composite f of x, that is g of f of x, that is f of x is x squared. Since I'm using x squared, there's no restriction on that. Plug that in, and that's the square root of x squared plus 2, but I know this is always positive for any value of x, so the domain would be all real numbers. There's no restriction on that. Example B, if I use f of x, I know that x cannot be a negative 1, and if I use g of x, I know x cannot be plus or minus 2. These are the only restrictions we have. So when I start with f of g of x, in part A, so to speak, that's f. G of x is x over x squared minus 4. Automatically, that domains carry with it. So far, I know this is the restriction. And now I'm going to take this and throw it in g. That's x over x squared minus 4 over, oops, I'm sorry, I messed up. That's x over x plus 1 over x divided by x plus 1 squared minus 4. Now I need to clean this up a bit. That would be x over x plus 1 divided by x squared over x plus 1 squared minus 4. LCD for the top and the bottom combined would be x plus 1 squared. So multiply this by x plus 1, top and bottom. This is missing nothing, and this by x plus 1 squared. Ignore the denominators. That will be x into x plus 1 over x squared minus 4 times x squared plus 2x plus 1. That is x squared plus x over x squared minus 4x minus 8x, distributing the 4 in, minus 4. That will get me an x squared plus x divided by negative 3x squared minus 8x plus 4. So far, the restriction is that x cannot be a negative 2, but then I have negative 3x squared minus 8x plus 4 cannot equal 0, or 3x squared plus 8x minus 4 cannot equal 0, and I have to see if that factors. X squared plus 8 over 3x plus a number equal 4 over 3 plus a number. Half of this is 4/3, square 16/9, and that would be x plus 4/3 squared equaling over 9. 3, 12, that's 28. So x equal negative 4/3 plus or minus 4 times 7. There we go. So my domain here would be, for this part, x such that x cannot equal a negative 2 or negative 4/3. I'm going to move this. I'm going to put this up here just because I'm running out of space. Plus or minus 2 radical 3 over 3. 2 radical 7. I should have gave it more space. I didn't pay attention. Okay, now we want to do h of x. We want to write it as f composite g. This is important in calculus. The way it works, you start by choosing g first. Now be careful with this. You're going to choose g every time. Let g equal. The one thing you can do, you can't let g be the whole thing and f be x, or vice versa. That does work, but that defies the purpose. The purpose is to get two functions that are different. You have a couple of options. You could let g equal x squared plus 2, and now we ask, what do you replace x squared plus 2 in to get this? Well, obviously that's f, the square root of x. That will work. Somebody might say, I want g to equal x squared. That's fine, you could do that. So what do you replace x squared in to get this? You replace it in x plus 2. If I replace x squared in there, I will get that. And here, if I replace this in there, I will get that. Either of those will work. There are multiple answers. Any one of them will do. Here, I could let f equal, say, the denominator, x cubed plus 4. That means whatever I let g equal, I replace that by x, and that will work. Of course, another option, let g equal just x cubed. F would be, well, if I replace this by x, it's that simple, but that's very important in calculus for something called the chain rule, something that's a must. Here, I could let g equal x plus 3. F must be, we'll take this out, replace it by x. That's what f is. Idea is fairly simple. Okay. And last type of problems, I'm going to do 3 of those. Well, if I let f equal, so we start with k, right? K first. Always k. Then g, then f. Well, if I let k equal, your choice, let's say I let that be, you have multiple choice, x squared plus 3. Then g comes next. Well, put that in there. Let's say 5 over x. That means f must be a square root of x. Think about it. If I replace x by this, now I have 5 over x squared plus 3. And if I take this and replace it by that x, that's my answer. Again, I have a couple of options. Either of those will work. I could let k equal the whole thing or just the radical x. It's up to you. If I let it be just radical x, then I'm going to choose g to be, I could say I want g to be x minus 3, just like that, and f would be 7 divided by x squared. Throw this in for k, you get square root of x minus 3. Throw this for x, and take this and put it in for that x. You'll get that. Again, there are multiple options. Any one will do. Here, it's a bit limited. Let k equal, let's say, x plus 7. G would be, well, if you take this out and put an x, 5 over x. And f would be just the absolute value of x. That will take care of business. Again, there are multiple options in these cases. Just do not let any one of them be just x. And that will work. And that's pretty much it for this section.